Hey guys, I wanted to make a video going over the 27.7 workbook problems, just because we didn't get a lot of time to work on these at the end of class. One thing I wanted to make a note of real quick, just because I was getting a lot of questions. Today we looked at proper length, and proper length was always bigger than just the length of an object in the stationary reference frame. And yesterday, proper time was always smaller. And that's because we were finding the time interval. And so the length of time between ticks of a clock was getting bigger, but that actual time interval is getting smaller. So just keep that straight, because it's important we're able to figure out which one's the proper length when we're looking at a picture. Okay, so 19 says, your friend flies from LA to New York. He determines the distance using distances speed times time. You and your assistants on the ground also measure the distance using meter sticks and surveying equipment. A says who, if anyone, measures the proper length. Okay, you measure the proper length. The person who measures proper length is always the one where, let me try to phrase this carefully. Basically to you, you're where LA and New York are. LA and New York are not moving relative to you. However, they are moving relative to your friend on the plane. So you're at rest with LA and New York while your friend isn't. So you measure proper length. B says, who measures the shorter distance? If you measure proper length, and proper length is always bigger, your friend is going to measure a shorter distance between those two cities. Okay, 20. It says experimenters in B's reference frame measure the length of A and find it to be equal to the length of B. Do experimenters in A's reference frame agree that A and B have the same length? If not, which do they find to be longer? So you guys, I found this one a little confusing at first because I was thinking, oh, if the length of A is the same as the length of B in B's reference frame, then it must be equal in A's reference frame as well. But we'll see that that's not the case. We're going to focus on the length of B to help us think about this. Okay, so we want to find the length of B. In B's reference frame, the length of B is the same as A. We were given that information in the problem. In A's reference frame, B is appearing to be moving. Because A is speeding past B, B is moving relative to A. Even though the velocity vector is attached to A, you could imagine if you were in a car going by your friend, to you, your friend would be disappearing in the rearview mirror. And so since B is moving relative to A, the length of B is going to be contracted. It's going to get smaller. And so, it says, which do they find to be longer? A would be longer. Okay, 21 says, as a meter stick flies past you, you simultaneously measure the positions of both ends and determine that the length of the meter stick is less than 1 meter. We know that meter sticks are exactly 1 meter, so what's going on here? It says, to an experiment in frame S prime, the meter sticks frame, did you make your two measurements simultaneously? So we've talked about, I think that was section 27.3 or 4, how two events don't have to be simultaneous in a reference frame that's moving. So two things could happen at the same time in one reference frame, but not happen at the same time in another. And in this case, that event is your measuring of both ends. Because we know that things don't necessarily have to be simultaneous, I'm going to say no. And because that meter stick is moving from left to right, to if there's a little person in the meter sticks reference frame, they would see you measure the left first. Okay, B says, can experimenters in frame S prime, so in the meter sticks frame, give an explanation for why your measurement is less than 1 meter? Because they would measure it as 1 meter. If they were writing on that meter stick, we know meter sticks are 1 meter long. So if they're not moving relative to it, they're just going to measure its length like normal. An explanation maybe they would have is that you didn't measure the ends simultaneously. So if that meter stick was going by you and you measured it, you can imagine when you took the rightmost measurement, the meter stick would have moved and your measurement would be inaccurate. Okay, C says, is there a reference frame in which the meter stick is measured to have a greater length than 1 meter? No. We only have length contraction, not length expansion. So there's no reference frame where we can make that meter stick appear longer. It's only going to ever appear shorter than a meter. Okay, I hope this helps you guys. Like I said on Monday, we're going to be doing practice with length contraction and time dilation so you guys can get this down. I know these conceptual examples can be challenging. Honestly, I find them challenging too. Like I said, your textbook is a great resource. I like how the sections kind of walk you through it. And also there's a lot of good sources on YouTube. I showed you guys that crash course video. But there's a lot more resources out there to help you guys understand this. Please let me know how I can help. And I will talk to you guys in class.